So hello guys, we had done vectors and almost vector additions. We have done all the methods, analytical and the graphical ones, and even I tell you something about the subtraction of vectors. So there is a good question in vectors addition, actually in subtraction. So I'll discuss that with you. Okay, then we'll proceed towards resolution of vectors. So what is it? It is actually like you know a body is moving in a circular fashion with a constant velocity, okay, with a velocity of 5 meter per second. Okay, so mm, take for example this is the center of the circle, and at this point, if I say it is here at this point A, and the velocity speed of the particle is, actually I'm talking of this, is 5 meter per second, and this is constant. Okay, from there to there it goes. So we need to find change in velocity. We need to find change in velocity, and the angle is given 60 degree. We need to find change in velocity, and the angle is being given as 60 degree here, with between, you can say that AOB, that arc, that angle is 60 degree. So at this moment, the velocity, the direction of speed is this, and the direction of velocity, you can say that at this moment it is this. Take this as v2, take this one as v1, though their magnitude is same but their direction is different. So actually what I need to find here, I need to find v2 minus v1. Actually this is nothing but a question of pure vector algebra, just the difference of two vectors, nothing more than that. Okay, so I need to find the difference of these two. So let's find the difference between these two vectors, else I can say the difference is not but just the addition of this and negative of v1. Can I say that? Now the only thing here is the geometry. I need to find the difference between these two vectors. So I can, just for instance, look into the diagram, and I can shift this v2 from here to here, and from here to here. This is all v2. Okay, I can shift it. So just look the diagram. So if I say what would be the angle between these two vectors, it would be, this is 90, this is 60, this would be 30, then this is perpendicular, then this would again be 60. Now previously I need to tell you that you can go, if I'm giving you the graphical method, then you need to go by v2, you are taking this as v2, then v1, negative of v1, you have to take this. Okay, but now you know the analytical method as well, and you know the direct formula. Okay, so in that direct formula you just need to replace by minus. Okay, so if I need to find the difference of these two vector, v2 minus v1, actually the thing is resultant, so it would be 5 square, that is the magnitude, 5 square magnitude, negative of 5 into 5, and cos of the angle between them, and the angle between them is 60, so cos 60 is half, so that would be 5. The resultant would be 5 only. The resultant vector, the magnitude of v2 minus v1 would be 5 meter per second only. Okay, so that was the thing I just need to tell you. Now let's come to the new topic, which is resolution of a vector. Resolution of vector. Let's talk of this. This is easy topic, resolution of vector. First of all, before telling you this, let's think of situation. If I gave you, there are two vectors and you just need to add them. Okay, vector A, vector B, that is their magnitude, vector A, vector B, and you just need to add them. So you know many methods to add them. But if I say there is another vector C, this makes an angle theta, I'll take for example alpha with the B vector, then how would you are going to add these vectors? Are you going to apply that analytical method, that formula again and again, or there would be something easy? And I'll tell you, yes, there is some easy method as well, and for that we are learning resolution of a vector. So what is the resolution of vector in the first place? So I'll tell you. Say for example, this is a vector having a vector, okay, and you can consider, you know, the x-axis, y-axis yourself. So if I say this is a vector A making a angle theta with the x-axis, so if I ask you, you can, you know, can you easily form a triangle like this? Can you drop a perpendicular here and name it at like P? With that, can you tell me what would be OP, magnitude of OP? Yes, it would be A cos theta. If I'm just talking about the magnitude of A vector is, say for example, this is A cos theta. And if I say you need to find the projection, okay, I drop another perpendicular over y-axis and take for example this is OQ. You need to find OQ, so go into that triangle, okay. If this is theta, so now this would be theta, and from that point of view OQ would become perpendicular, and OA again is the hypotenuse, okay. OR is the hypotenuse again, then OQ is A sine theta, okay. So these are actually the projection, or else I can tell them OP, because it is the projection on x-axis, so I call it, you know, resolution of vector in x-axis. And OQ, it is the projection of the vector A in the y-axis, so I call this projection of vector A in y-axis, or I resolved it in y-axis. So thereby I resolve the vector vector A whose length is OR or A magnitude into x-axis and y-axis. So resolution of vector is actually the projection of vector into the x-axis and y-axis. And you might be wondering, what do you mean by projection? Projection is nothing. Say for example, this was the A vector, okay. So you put the light here and project it over the vector. Then just think of the shadow would be like this, na? So the length of the shadow, and you would have a top view over that, so it would look like a straight line. So the length of the shadow, it would be the x-axis, projection over the x-axis, and when you project the light from here to the shadow here, the length here, the projection over the y-axis. Now don't cram it like x-axis or y-axis, it depends on the angle. What I said, just, you know, pay attention, it depends on the angle. Say for example, this is y-axis, this is x-axis, and I give you this angle theta, and this is again vector A, okay. So now what would be the case if I say what would be the projection of A vector on the y-axis? Now it would be A cos theta. You would see from here, and you need to find the shadow length. So the length of this would be A cos theta, because theta is there, na, okay. So part of that would be A cos theta, because this would become base over here, okay. And what would be the projection on the x-axis? Now theta, this become theta, and this side would become perpendicular, so this would actually A sine theta. So do not cramp it, okay. It varies with the angle. What is the given angle to you? Now we'll discuss some question. This is not a problem. So if I say to you, there's a vector A and the length of the vector is 5, okay, and with the x-axis and y-axis, this vector makes an angle of 37 degree. So if I ask you AX and AY, it is actually resolution of it. I have resolved these vectors in the x-axis and y-axis, and I'm asking you their magnitude. Okay, so now the thing is, let's learn the resolution. If I need to find AX over here, I need to find the length of this. Actually, that is the AX. Okay, so let's come to the length of this part would be A, that is 5 cos 37, and that would be A sin 37. I've told you what is cos 37. Cos 37 is 4 by 5, so that would be 4, and sin 37 is 3 by 5, so that is 4 by 5, and that is 3 by 5. Okay, and that would be 3. So these are the AX and AY, projection of vector in the x-axis and the y-axis. Now let me ask you another problem to solidify your concept. So if I say there is an plane and it is flying with a velocity of 100√2 meter per second, making an angle of 45 degree with the horizontal with the ground. Okay, with the horizontal. So what you need to do, find its component, x and y component, find its perpendicular and parallel component, or what I mean to say, find velocity x and y component. We just need to find that. Okay, so let's talk of solution. So if the velocity is 100√2 and it is making an angle of 45 degree with the x-axis, with the horizontal, x-axis means horizontal axis, y-axis means vertical axis. So the thing is, what would be is x component, x-axis component, horizontal component, 100√2 into cos 45. What is cos 45? 1 by √2. So eventually it become 100. And if I ask you what would be the vertical component, 100√2 velocity into sine 45, that would again be sine 45 is 1 by √2, √2 cancel out, so it would be again be 100. So Vy, so both the component would be same. And even I tell you, you remember in the vectors, if the two vectors magnitude are same, the angle between them would be, and the resultant would form an angle of 45 if the magnitude of two vectors are same. So the resultant would form, and they are at perpendicular to each other. They are perpendicular to each other, two vectors, and their magnitude is same, 10 so the resultant would form an angle of 45 degree. Okay, so this is the same thing. Okay, we are reverse engineering the facts. So we have done this. Now let's talk something more about it. Unit vectors, very important. Unit vectors. What are unit vectors? Unit vectors are vectors having a magnitude of only one, unity 1, and they are just used to represent direction, just direction and nothing else. Now you'll be wondering, what does that mean? Say for example, I come to a coordinate system. Okay, so this represents x axis, this represents y axis, this represents negative of x axis, this represents negative of y axis, this represents z axis, this represents negative of z axis. Okay, now I need to represent x axis, this direction only, this eastward direction only, not bothering about the magnitude. There is a vector of magnitude 1 and I just need to just represent positive x axis. There must be some symbol which only represent